Let's take a look at a few features from our molar mass of a gas lab. I copied and pasted this image from the recent homework worksheet for those who may have been absent or really didn't follow what we were doing in the lab. We collected a sample of gas over water or underwater. The gas that we used was butane from a butane lighter. We did not do the reaction shown in the picture here. But we used lighters because they provided a source for the butane gas. And we held our arms underwater so that we could collect the gas underwater to keep it from mixing with the air, right? Gas is often collected underwater, or we often say over water, to keep it from mixing with the air. We collected it inside of a gas tube called a eudiometer tube. The gas that we collected was butane. But since gas is bubbled through water during the collection phase, the sample that we collected also contained water vapor. And so that is something that we have to calculate and subtract from the butane during our calculations. And I definitely wanted to point that out to you today. So the gas we captured contained both butane and water vapor. You should have your data set hopefully filled in by today. 2 lighters, 2 trials, you'll do the 2 sets of calculations, and then I think it tells you to average them somewhere in the process. So I wanted to talk to you about number 2, because it says use Dalton's law, and that may not be a name you're familiar with, but it is the point of what I was just discussing. So it says calculate the pressure of the butane alone. So the pressure of the butane plus the pressure of the water vapor that we collected in the tube should have been equal to the pressure in the atmosphere. So remember in your data, we looked up barometric pressure. This is the pressure of the atmosphere, so you'll just plug that in. And then the pressure of the water vapor is based on the temperature of the water. So we looked that up as well. So to find the pressure of the butane, which you're asked to find in number 2, you'll simply be subtracting the water vapor from the atmosphere. It's a small number that you'll be subtracting just to make sure we're only talking about the pressure caused by the butane gas. Let's take a look at number 3. It says use the ideal gas law to calculate the moles of butane. So we will not be using the mass of butane to find the moles. We'll be using the ideal gas law. So let me remind you how that looks. The pressure is the pressure of the butane. Because we're finding number of moles of butane, we're going to use the pressure of the butane from up above. The volume you should have collected here. And I just want to remind you that when we collected the butane gas inside the tube, and that gas contained a little water vapor as well, we set the level of the water inside of the tube at the same height as the level of the water outside of the tube. And this is why, because we wanted atmospheric pressure to be the overall force limiting that volume, so that we could then later say that this volume is accurate based on the things that are pushing against that water inside of that tube, based on our knowledge that the butane and the water are pushing directly against the atmosphere. We want to have the level of the water equal to that of the atmosphere. So that was something that I asked everyone to consider in lab. But we have our volume, so you can just plug that in. N is the thing we're trying to find. R is the universal gas constant. And of course, T, the temperature of the butane, is the temperature of the water. We made sure of that when we soaked our lighter in the water to begin with. We were trying to let the temperature in the lighter and in the water become the same so that we could use that temperature. So this is the N that you'll be solving for. You have all the data there. And then moving forward, it says here you'll subtract the mass before and after to find the mass of the butane. And its molar mass is the mass over the number of moles that you just calculated.